a problem on a randomized algorithm. Let's start. Firstly, I'm writing to ChatGPT. Can you give me a basic practice question on randomized algorithm? Then enter, click enter. ChatGPT answered me like that. Certainly, here's a basic practice. Yes, you are given an array of integers, and your task is to find the maximum element in the array using a randomized algorithm. Implement a randomized algorithm to find the maximum element in the given array. Your algorithm should have an equal probability of selecting an element from the array. Hint: you can use the concept of random sampling to select elements from the array with equal probability. Feel free ask to question. Okay. Now I will think how can I solve this problem, and I will back again. Yes, I thought how can I solve, and let's start. Firstly, I'm writing definition randomized maximum element array and an equal length array. Then if n equals 0, if n equals 0, return what? Return none. Then random index equal random dot run int 0 n minus 1 max element maximum. Oh, sorry. Yeah. Oh my god. Again. Sorry. Max element equal, I will write like that, maximum element equal random index, yes, maximum element equal array random index maximum element equal array random index equal random round int 0 and n minus 1. Then for num in array if num greater than maximum element then maximum element equal num maximum then return maximum element it is my solution. Am I right? Yes, your solution looks correct. Your randomized maximum element function input array, yes. Now, if it then initializes maximum element with a random element from the input array and iterates through the array to find the maximum element. If a number maximum, yes, maximum update final function returns the maximum element from the array. However, there is a small indentation issue in your code. Return statement in such loop should be aligned with the for loop. Okay. Yes, let's me. Now your function should work as expected. Okay. Thank you. Then other question. Let's start. Can you give me a basic question on analyzing running time of a randomized algorithm? Yes, I'm asking this question. ChatGPT answered me. What is that? Suppose you have an array of n integers and you want to find the median of the array using a randomized algorithm. Randomized algorithm works as follows. Randomly pick an element from the array uniformly at random and use it as a pivot. Partition the array into elements smaller than the pivot, equal to the pivot, and larger than the pivot if the pivot is the kth element in the sorted array O-based index, then return the pivot as the median. Okay, analyze the worst case time complexity of this randomized algorithm in terms of the number of comparisons and might made during the partition process. Compare the worst case time complexity of the randomized algorithm with the worst case time complexity of the deterministic quest sort algorithm, which uses the pivot as the first element of the array. Okay, here for a part A, consider the worst case scenario when the pivot chosen is always the smallest or largest element in the array. For part B, compare the partition process of the randomized algorithm with the partition process of deterministic quicksort. Okay, I understand this question. I understood this question, and I will think how can I solve, and I will back again. Yes, again, let's start. I understood this question, and I thought like that. Firstly, randomized algorithm. Firstly, I will solve A. A is in randomized algorithm for median. Time number another worst case time terms. Yes. Imagine you have a list of numbers. In this algorithm, we randomly pick a number from the list and use it as a reference pivot. We then divide the list into three parts. Number smaller than the pivot, numbers equal the pivot, and numbers larger the pivot. If the pivot happens to be the kth smallest number in the sorted list, we found our median. However, if we always pick the smallest or largest number as the pivot, the algorithm becomes slow. In the worst case, where we always pick the smallest or largest number, this method can take a long time, very long time. It may take a number of comparisons proportional to n square, where n is number of elements in the list. I'm writing this. For A, and the worst case where we O O square. Then we will do B. Deterministic quicksort. Quicksort is another sorting algorithm that works by selecting a pivot. In deterministic quicksort, we always choose the first number in the list as the pivot. If the list is already sorted or nearly sorted, this method can be slow because it leads to unbalanced partitions, making the algorithm take a long time. Just like the randomized algorithm, deterministic quicksort can also take a long time in the worst case, which is proportional to n squared, where n is the number of elements in the list. Yes. But I will have, how can I say that? Deterministic. I will deterministic good sorts can also take a long time. Take a long time. Take a long time. In the worst case, which is proportional to square, where n is the number, where n is the number, where n is the number of elements in the list. Yes. In comparison, both the randomized algorithm and deterministic quicksort can be slow in the similar situations where unbalanced partitions occur. The randomized algorithm tries to mitigate this issue by randomly selecting pivots, making it perform better on average, even though it can still be slow in the worst case. In summary, both methods have the potential to be slow in certain situations, but on average, the randomized algorithm performs better due to its random pivot selection. I hope this explanation clarifies the concepts for you. Let's then like that. What I say, what I will write. Both methods. Have the potential to be slow to be slow in the certain situation, in the certain situation, but on average situations, but on average, the randomized algorithm, the randomized algorithm performs better due to pivot selection. Yes. What time? Oh. Security answered me like that. Yes, you're absolutely right. For part A, in worst case scenario where the pivot chosen in always the smallest or largest, yes, like me, and square because essentially reduced selection sort where array sorted in one element. For part B, deterministic quicksort each shows pivot as can also go to the complexity worst case, yes, because it leads unbalanced parts making the algorithm inefficient. However, as you correctly pointed out, advantages of the randomized algorithm that is random pivot selection worst case and on average algorithms perform better than deterministic quicksort because it inconsistently bet on certain inputs, leading to expected average case time complex of A, O, and log n. Due to the balanced transition, your understanding accurate, both methods have the potential to be slow and statistics used, but on average, the randomized algorithm of performance deterministic quicksort yes, due to its random pivot selection. Well done. Okay. Thank you. Okay. This part is that I finished.